so cold. When I came this morning, it was 32 degrees. My car was completely frozen over. So cold.
Yes, freezing. Right now, it feels like it's like 50.
Yeah, it is. Okay. Sorry, Zoomers. Let's start the recording and get this going. Okay, test. Looks like we're good. All right. Oh, that can go away and share. Yay. All right. Welcome to semester 2 review session. So we meet every Tuesday at 10:30 and I record them. So if you cannot make a session, if you go to the announcement and you follow and it says videos from last year's videos from the sessions, all of last year, I don't know if those are last year's or 2 years ago. Okay, I can't exactly remember, but previous videos are on there and you can watch those. Or after I do this, this will be recorded and I will put that up onto that page as well. So if you can't make the session, there will be videos. Okay, you're going to see today we are doing a lot of review and then a little bit of new. Okay. Are there any questions? Oh, and you can get extra credit homework points. Okay. So this semester, there are 2 ways to get extra credit homework points. You can attend the session, and either in person, or if you are attending in Zoom, I need you to participate by answering questions. They don't need to be correct answers. Do your best, or even question mark if you absolutely have no idea. Okay. Or come in and work for 30 minutes in my classroom with me. You come in and you say, hey, I'm here for homework club. And I say, okay, great. It's good to send me a message through Canvas inbox to let me know that you're coming. And you can do 30 minutes of math here with me and receive 5 extra credit homework points that way as well. Now, disclaimer, at the end of the grading periods, the homework grade maxes out at 100%. You can't, if you did all of this, you would have like 150% homework. You can't do that. Homework grade maxes out at 100%. So Zoomers, I just ask that you participate. I will periodically be asking questions and you are going to just answer in the chat. Okay, so thank you for joining me. Welcome. And right now, Zoomers, if you could just say hi to me in the chat and we will get started. I'm having a little trouble getting going at the new semester. So
are the windows covered?
Hmm?
Are the windows covered?
The windows are covered. I think they're either power washing the walls or painting.
Oh.
So yes, so it might get really loud. Good morning. Okay, I am back. Yeah, it's a little crazy here.
Yeah.
So I know, I kind of don't mind, but then you're like, huh, wonder what's going on out there. Okay, sorry. They will be power washing or painting my outside walls. So let's hope it doesn't get super loud. Okay, let's get going. Now find the product. You're going to find that there is a lot of review today. Okay, so find the product. We are going to demonstrate the box method to find the product. Okay, So 7r minus 1. Okay, Zoomers. What goes in that box right there?
49. Oh, is that a 7?
That is a 7. Yes. Yeah, Zoomers, anyone have a guess? 49 r squared, right? Because we know that r times r is r squared. Yeah? So how would you type that? Zoomers, you're probably thinking, I don't have an exponent. You would go, whoops, 49r squared. That's how you would type it in. Okay, and you may have to do that for some Canvas quizzes.
But it was an R minus 7.
Oh my gosh. Oh, no wonder. I am so sorry. Woo. Okay. Oh, you guys, I'm so sorry. And this is on the video. Okay. No wonder you guys are so quiet. So 7r minus 1 and r minus 7. Okay, let's do this one. Okay, Zoomers. What would go in that, excuse me, that box?
7.
Yeah, so we have 7r squared. There's really an invisible 1 there. Multiply the coefficients, little invisible ones, add the exponents. Okay, 7r times negative 7, negative 49r. So now we have 1r times negative 1 is negative r, or you could say negative 1r. And then negative 1 times negative 7. Zoomers, what goes here? And Zoomers, you could either do direct message to me or type it in chat to everyone. So Zoomers, if you could just answer my questions into the chat, that would be great. So first step, we multiply. Second, what does this stand for? Combine like terms. Yeah, combine like terms. We see that we have like terms right there. So we're going to have 7r squared minus 50r plus 7. Now, how come the exponent didn't change right there on the r when I took negative 49r and I combined it with negative 1r?
Because when you're adding, it doesn't count.
Okay, when you're adding, you don't change the exponent. You change the exponent when you are multiplying. Okay, so that is demonstrating the box method for, another way to call this is FOIL. Okay, but we're going to demonstrate the box method. Okay, factor completely. We are going to demonstrate the method used in the review session. So we see the categories. This category is A equals 1. What the heck does that mean? A equals 1. That means the coefficient in front of the squared term is invisible. If it's invisible, it is a 1. So the whole world categorizes factoring as A equals 1. I call it easy diamond. Okay, easy diamond. So because the coefficient of the x squared is 1, even though it's not showing. Okay, easy diamond. What goes on top of our diamond?
Negative 10.
Negative 10. And on the bottom?
3.
Positive 3. Okay, So now we need to look at the chart of factors. Oh, let's go back here. Okay, so I need two numbers that multiply to get -10 and add to get 3. Two numbers, multiply on top, add on the bottom. So two numbers that multiply to get -10 and add to get +3. Okay, I am totally blank. I cannot figure it out. So I'm going to look at the chart of factors. I need two numbers that multiply to get -10 and add, right? Add to get +3. 5 and -2. Yeah, that's what you said, right? +5, -2.
And when you put the negative sign in any number, it doesn't matter.
Now, what's the difference between these two? The top one is going to be +5 and -2, because when I add +5 and -2, I get 3, right? This one is going to be -5 and +2. Because when I add -5 and +2, it'll give me a -3. So both of these give me a -10 on top. Only +5 and -2 give me a +3 when I add them. No, go away. Okay. Okay, so +5 and -3. And because this is easy diamond, those are the answers. X + 5, X - 3. Shoot. Oh my gosh. Okay, you guys, I'm having a really hard time. 5 times -2 is -10. Boy, I am glad you are here to catch me. You're going to have to watch me. My brain I'm having a little brain fog. So 5 times -2 is -10. 5 plus -2 is 3. Okay, if you're new to this session, it's not always this bad. Okay, so factor easy diamond method, demonstrating the easy diamond method. Okay, so let's talk about the 4 types of factoring. We have easy diamond. These are a little bit out of order from what we talked about last semester. We have GCF. We have difference of 2 squares. Difference of 2 squares. Difference meaning subtract. And then we have difficult. So we have rainbow, diamond, box. Okay, now notice all of the terms in my expression have a V in them. All of them. They have a common factor. So this is the GCF method. It could be GCF and then one of the others, but this one is just GCF. So if this is V times V and 7 times V, this is the opposite of distribute. So the V's are going to move to the front, just like with distribute. And what's left? V plus 7. Okay, GCF factoring. We are demonstrating the method of GCF factoring. Okay, we could put it in a box and work the box backwards. V squared and 7v. The common factor goes there. V times v is v squared, v times 7, and then the answer would be here. So the box would work, but we don't usually use the box. Okay. Okay. Let's do number 5. Now, here's another example. Okay, we'll just do this one. We notice that x squared is a perfect square and 1 is a perfect square. So we're going to write them as 2 squares, right? Now this is weird that 1 squared is 1, so that 1 didn't change. We're going to do another example after this. Okay, difference of 2 squares. Now, I can show you why if you want to stay at the end. This becomes x plus 1 and x minus 1. Okay, if you want to see why, I can show you at the end. Now, because 1 is very strange, let's do another one. So if we look at the chart of factors, another perfect square. See, look at the perfect squares. Yeah, you could see them on the chart of factors. Turn the chart of factors over, and there are the perfect squares circled in red. 1, we just used 1. 1 is a perfect square. So let's use 16 and 25. Do we see that those are both perfect squares? Okay, so let's make up a new problem. 16x squared minus 25y squared. A little more complicated because we did an example that was too easy. Okay, step 1, write these as perfect squares. Notice this must be subtraction because this is the difference of 2 squares. Step 1, write them both as perfect squares. So 16 is what squared? 4x squared, right? Not yet. That's a y, by the way. 25 is 5. So this is step 1. 16x squared is 4x, quantity squared. 25y squared is 5y, quantity squared. Now, okay, difference of 2 squares will always end up looking like this. We have 4x plus 5y and 4x minus 5y. And if you want to see why this works, we could make a box just like we did with number 1, and it would demonstrate why it works. Okay, so we can talk more about this at the end. Stay at the end, and we'll make a box and we'll see why this works. Okay, now let's go to number 4. Notice this is not an easy diamond. This is A is not equal to 1. It has a coefficient in front of the squared term. So I have 2 choices. I can either try to GCF factor it out, or I would have to do rainbow diamond box. But if you notice, 4, 28, and 72 can all be divided by 4. So I'm going to use GCF, factor out that 4. And I'm going to have m squared minus 7m minus 72 divided by 4 is 18. Okay, now that I've factored out the 4, this becomes easy diamond. So if it's easy diamond, I make a diamond. And what goes on the top of the diamond? All right, so negative 18 on top. What goes on the bottom of the diamond?
-7.
-7 on the bottom. So I go to the chart of factors. I need two numbers that multiply to get -18 and add to get -7. So I'm not going to bounce back and forth. According to the chart of factors, what two numbers multiply to get -18 and add to get -7? Okay, we know it's 9 and 2, right? One of these needs to be negative, and when I add them together, I'm going to end up with a -7. So since the bottom is negative, I want the bigger one negative. Yeah. So I have 4. Now, easy diamond. M minus 9, M plus 2. So GCF, easy diamond. Next week, we're going to talk about rainbow diamond box. Okay, we're going to keep going. We can go over them again at the end. Stick around if you still have questions. Now, we are going to demonstrate. Okay, splitting this into the biggest perfect square and the leftovers. There are different methods to do this. We are going to split this into the biggest perfect square and the leftovers. Now, if I look over at the chart of factors, by the way, if you do not have a chart of factors, they should be in the module 1. If not, I have them here. And I can make sure that they're in module 1. So we see that 8 is 1 times 8 or 2 times 4. 4 is the biggest perfect square. So I split it into, good morning. Thank you. The biggest perfect square and the leftovers.
Oh, didn't I get this one? I remember last semester.
Yes, we talked about it last semester.
Yeah.
So on the Canvas quiz, when it says, what is the biggest perfect square? You type in 4. And when it says, what are the leftovers? You type in 2. Okay. So what is the square root of 4? 2. Now, square root of 2 is like 1.14. Those are the leftovers, cannot be simplified. So that is demonstrating the biggest perfect square and leftovers method. Okay, let's do another one. 32, I look at the chart of factors. 1 times 32, 2 times 16, 4 times 8. That's what you'd get from the chart of factors. So I want the biggest perfect square and the leftovers. Now, be very careful. Why is this one a little trickier?
There's two.
There are two perfect squares. Yeah, let's look at our, look, 16 and 4 are both perfect squares. Can I just take any perfect square I want? No, I must take the biggest perfect square.
Yeah, I was getting it wrong like last semester. But I was like,
Okay, so the biggest perfect square is 16. The leftovers are 2. Yeah, because we're using this pair. So the biggest perfect square is 16. The leftovers are 2. So 16, the square root is 4. 2 is not a perfect square. So it just comes down. Okay. Number 8, we talked about this in September. Notice we started these topics in September. We're going to go deeper into the concept of quadratics. Okay, so identify the vertex. Yeah, Zoomers, can you guess what the vertex is? The x coordinate is the opposite of that one right there. So the x coordinate is +2. The y coordinate is the same. Yeah, opposite for the x, same for the y. Okay. Now, this one's a lot of work. Convert to standard form. What is the first step that I have to do?
oh no, you have to subtract.
Not yet.
Okay,
Convert to
divide.
standard form. I need to make a box. Okay. So I need, step 1 is to do the exponent. So I need to multiply x minus 4, x minus 4. So I need to take it from an exponent into that thing in the parentheses, the expression in the parentheses times itself. Okay, so we need to make a box to multiply x minus 4 and x minus 4. X times x is x squared, x times -4, -4x, -4x, and what goes here? +16. Okay, combine like terms gives us x squared minus 8x, right? The exponent does not change when you add them together, plus 16. So I multiplied, I expanded the exponent. So 3 times x squared minus 8x plus 16 plus 1. So I did the exponent first. Or you could say I did the parentheses first. Okay, what's next? Distribute 3x squared minus 24x plus 48. Did I forget anything? What did I forget?
The one?
Ah, I lost my +1. So 3x squared minus 24x plus 49. Okay, kind of a lot of work. Involves making a box.
That was hard.
Yeah, it's not that bad. Okay, evaluate. Now, practice with the calculator. When you come in to take your exam with me, you will be using, will you grab one for yourself? In the Lysol box. Yeah, that one. You will be using one of my calculators. So we are going to substitute -3. Plug it in with parentheses, and I'm going to do it in my head. This turns out to be -27 and +9. Yeah, look at this. Why is that +9?
Because two negatives.
Because two negatives, negative times negative equals positive. But three of them, we're going to end up with negative. Yeah, so what do we get here? We're going to plug that into the calculator and we're going to get -21. Okay, we're not going to spend too much time on that one. We're going to move on. Okay, number 11. Now, we used to teach, I used to make students complete the square to identify the vertex, and there's an easier way. We're just going to do it the easy way. Okay, how do we find the vertex? -b over 2a. Yeah, we kind of reviewed this first semester. We're coming back to it. So the x coordinate of the vertex. So a is 1. B equals 4. Notice the C term does not affect the vertex. So the x coordinate of the vertex is -b over 2 times a. -b over 2a. So the x coordinate of the vertex is -4 divided by 2 is -2. Okay, how do we get the y coordinate of the vertex? We're going to plug it in. So y equals, with parentheses, -2 squared plus 4 times -2. It's very important, especially when you're substituting negative numbers, that you include the parentheses. So we're just going to do this in our head, although it's good to be able to do it in the calculator correctly. -2 times -2 is +4, right? If you're using a calculator, remember that your parentheses. In your head, -2 times -2, +4, plus -8, plus 1. Y equals -3. Okay. So the vertex is -2, -3. Okay. Now, so step 1, we found the vertex. That was actually step 2. Step 1, parent graph. An exponent of 2 makes what shape?
Like a U?
A U. And A is positive. It's a positive. It's a happy U. If there was a negative right here, if there was a negative right there, it would be upside down U. Okay, so we know it makes a U. Ooh. That's not distracting at all. Okay, so we write the parent, we find the vertex. Step 3 is make a box or make a table. 3 points. The vertex goes in the middle of my table. Negative, -2, -3. So now I'm going to go 1 to the left and 1 to the right. Yeah, 1 to the left, 1 to the right. Okay, we're going to speed up a little bit. So now you need to plug in -3. So -3 squared plus 4 times -3 plus 1, which is +9 minus 12 plus 1, which is -2. Okay, let's plug in -1. -1 squared plus 4 times -1 plus 1, which is +1 plus -4 plus 1, which is
-2.
if this is a parabola and you have the vertex in the middle, those should agree. So -4, -2, and -1, -2. So parent graph, vertex, box. So this is a sketch of the graph with 3 points. There's also, we'll talk about A later. Okay. Do not do. I think you get the idea. We don't need to do 2. For joining me today or watching this video, do not do. If you're watching last year's video, you have to do it. Because I didn't say do not do last year. Okay, find the equation of the quadratic that passes through the points. Okay, so we're going to use, okay, first of all, let's talk about this. If I have y equals 0, that means 4, 0 and -2, 0 are, if the y value is 0, the x values are the x-intercepts. Okay, so we've had vertex form. We are going to talk about x-intercept form. And we did not, so this is new. We did not talk about this last semester. Okay, so here is x-intercept form. X minus, we're going to call it B, and X minus C. I have a chart with formulas and I don't remember what variables we used, but this is good. So the x-intercepts, A, we don't know. B is 4. C is -2. So see how the x-intercepts are going to go there? Okay. So if you're given the x-intercepts, y, we don't know A, we're going to have x minus 4 and x minus -2.
Well, you can use
Yes.
relatively-
Oh, you watch the notes. Yay. Okay, good point. It is helpful to watch the notes on Monday before the review session on Tuesday. Okay, because then when I introduce something new, it's gonna look familiar. Now I'm gonna clean this up. I'm not gonna go minus a negative. Yeah, keep change. Okay. Now, what am I gonna do with the point? 1, -27. Okay. X is a good variable. Y is a good variable. You are not done if you still have A there. So I need to solve for A. So what can I do with the point 1, -27?
Whatever you put -27 in the A.
I'm going to put -27 in for ding, ding, ding. So I'm going to put 1 in for X and -27 in for Y. Okay, so I'm going to plug in my X. I'm going to plug in my Y. And I'm going to use that to solve for A. So I have -27 equals I'll leave the A here. -3 times 3. So -27 is equal to -9A. So divide, A is equal to 3.
Yeah, 20.
20?
They're
All right.
labeled. They have
Perfect.
part number 2 on them.
Oh my gosh, love it.
I kind of wish I put 1 KL, so
Okay, sorry about that.
Yeah.
all right, I'll let you guys be back.
Thank you. Okay, so here's our equation. Y equals 3. And then we have X minus 4, X plus 2. Okay, so that is new material this semester. You have not seen that. Okay, so if you have the 2 points with Y equals 0, you have X-intercept. You have the 2 X-intercepts. That means you are going to use X-intercept form to get your equation. Okay? Okay. How about this one? By the way, that's a 5. You know what? I think, okay, we're good. So this one is do not do. Okay, but I do expect you to understand, we will do this one in the future, but I want this to process. If you are given the X-intercepts, That's how you write your equation. Let's go on to number 15. This is the bunny problem. Guess what? The bunny problem. We're going to practice it. Thank you. We're going to practice it every week. Guess what? There's a word problem on your exam. Guess what? It's the bunny problem. Okay. And you know how that works in this class. Like I tell you, you must know this. And guess what? It shows up on the test. Okay. Now it'll look just like this. And every week the numbers change. This week, the numbers come out to be decimals. Not ideal, but okay. Suppose you're enclosing a rectangular region to create a rabbit cage. 30 feet of fence to build the largest pen. Oh, largest possible. Let's call that the max area. Okay, so you build a cage using a building as one side. So we're going to draw a sketch. And I can't draw a straight line with this. Okay, here is the building. Yeah? Okay. So we see the fence. This is building, that is fence. Okay. Write an equation that gives you the area y. So area is y. The width is x. Do we see that both of those are x? Yeah? The width of the pen is x. Do we see that it's against the building? Yeah, so that doesn't need a variable right there. We need a variable for right here. Are you ready for the hardest part of the first time you see it? Yeah? What am I going to call this? Now, I have 30 feet of fencing. I've used X, take that away. I've used X, take that away. I had 30. I took away X and X. So the hardest part of this whole problem is the length of the pen is 30 minus 2x. Does that make sense? I had 30. I took away x over here and x over here. That leaves 30 minus 2x. Now you're going to see this problem over and over. This number right here is going to change, which is going to change right there. Okay. So are we good so far? Okay. It's hard. Okay. Give an equation for the area. So area is the y. Area of a rectangle is length times width. X times 30 minus 2x. Everyone see where I got that? I used base times height, right? Length times width. Notice it's this times this. You don't use both x's. Area of a rectangle is length times width. If you don't like the way I'm describing it, you might want to watch last year's video. Maybe I described it better last year. Okay, so we have area is y, width is x. Or we could distribute. Are you with me? Okay. Now, the max area. The max area. What type of graph is that going to make? Exponent of 2 makes, oh, it's a U. Okay, let's put it in order. Okay, so we're going to put it in order. And I want to find the max. I want to find the max area. Let's make a little sketch. Exponent of 2 makes a U with a negative in front, with a negative coefficient on the x squared. This is not a regular U. What is this? Upside down U. Okay, so the max area, can you see that it's going to be right there? That's where the max is going to be. Right here. The sleeping U, the max area is right there, the max value. Okay, which is also called the vertex. Okay, so when it says find the max area, it's what we're doing is find the vertex. Okay, so what tiny little formula do we use to find the x coordinate of the vertex? X coordinate of the vertex.
Isn't it usually like the inside, but it's a 0? It's a positive 2. Okay.
Look at problem number 11. Everything we've been doing all morning has been leading up to this problem. How can we use what we learned in number 11 to find the max area, which we're going to find from the vertex?
Negative.
Okay, so the x coordinate is negative b over 2a, which is negative 30 over 2 times negative 2, which, sorry, when I wrote this one, comes out a decimal. What is that? Nah, positive 7. So the x coordinate is positive 7.5. Now, I want to find the max area. To find the max area, is 7.5 the max area? No, to find the max area, I know the width is 7.5. To get the area is the y value. So negative 2 times x squared plus 30 times x. Should give you 112.5, which is the max area. Okay. By the time it comes to take the test, we will have practiced this a couple times and it's not going to be as bad. This is the way math is. The first time you see it, it looks hard. And then you practice it and it's not bad. Okay, moving on. Solve using the zero product property. Step 1 is Step 1 is put in correct order. Step 2 is factor. Step 3 is split. And step 4 is solve. This is already factored. So we are only going to do split and solve. Okay, 0 to both of them. If this times this equals 0, a plus 7 must be 0. And or a minus 6 must be 0. Because that's the only way to get to multiply two numbers and get 0. So a plus 7 could be the 0. A minus 6 could be the 0. Split and solve. A equals -7 or +6. Okay, number 17. Solve using the zero product property. It's already factored. So all we have to do is split and solve. And what do you get? -7 and +5. You end up getting the opposite. Okay? Okay. Okay. Order, factor, split, and solve. We need to get 0. Move everything over to one side, 0 on the other side. Order, factor. What type of factoring is this?
Oh, the district.
The undistribute one, right? The opposite of distribute, GCF. So this is n times n, 7 times n. So we factor out an n. And we get n plus 7. Factor. Now I have two n's. So I split n equals 0 and or -7 plus n could be the 0. Order, factor, split, and solve. So we're going to -7. N could be 0 or -7. Now on a test, you could probably guess and get the 0. But number 1, you didn't show your steps. And number 2, you're not going to get the other one. Okay, number 19. Order. I am going to move the 48 over. I see that this is an easy diamond. I look at the chart of factors. I need two numbers that multiply to get positive 48 and add to get negative 14.
67.
So -6 and -8. When I multiply, the negatives cancel. When I add, same sign sum. So easy diamond. Okay, order, factor. Oh, that's funny. Order, factor, split and solve. P equals +6 and +8. Okay, if you have questions, you can ask. Otherwise, do not do. Now notice something's different here. Notice there is no middle term. No n term. So we could factor, split, and solve, but there's a shortcut. When there's no middle term, you're going to move the 10 to the other side. And we're going to solve. Divide by 7. N squared equals 1. Take the square root. Square root of 1 is 1. So let's check. 1 squared will give me 1. -1 squared will also give me 1. When you have an exponent of 2, you are expecting 2 answers. 1 or -1. We did those last semester as well. Okay, let's isolate my squared term. Subtract 5. 64x squared is equal to 36. Divide by 64. X squared, and I'm going to reduce. I'm going to divide them both by 6. No.
Well, don't you find the square root and the square root back?
Okay, I'm going to find the square root. I could divide them by 4. Okay, let's just find the square root. Okay, x squared equals 36 over 64. I notice those are both perfect squares. So I'm going to take the square root of both sides. So x equals square root of 36 is 6, square root of 64 is 8, or -6/8. So you could either reduce before you take the square root or after. And then reduce. Okay. Now, how could I graph finding the x-intercepts? To find the x-intercepts, you factor. Okay, easy diamond. I need two numbers that multiply to get 3 and add to get 4. Okay, 1 times 3. So this factors into x plus 3, x plus 1. Solve. So I'm going to plug in y equals 0. Okay, so if y equals 0, that means we have the x-intercepts. So the x-intercepts. What are the two numbers that will give me 0? The two numbers are -3 and -1. So -3, 0 and -1, 0. How can we find the vertex? X equals -b over 2a. So, which is -4 over 2, which is -2. Plug it in. So y is equal to -2 squared plus 4 times -2 plus 3, which is 4 minus 8 plus 3, which is -1. Okay, so the vertex is -1, -2. Now, without doing this, could you have told me that the vertex was -1, was the x coordinate of the vertex was -2? Yes, because you know it's going to be directly in between the two x-intercepts. So I have the x-intercepts and the vertex. X-intercepts and vertex. We are almost done. Yeah, can you stay with me for a couple more minutes? Last problem. Okay, x-intercepts. So we plug in y equals 0. Factor. This is GCF. So I'm going to factor out negative x, which leaves x plus 2. Yeah, do we see why that's a plus? Because I pulled the negative out of both. Okay, the 2x intercepts. Y equals 0 for both. I'm going to split negative x is equal to 0 and x plus 2 is equal to 0. So x is equal to 0 and negative 2. Okay, so we have 0, 0 and negative 2, 0 are my x-intercepts. Vertex. X equals negative b over 2a. Which is negative negative 2 over 2 times negative 1. Which is 2 over negative 2, negative 1. Now, why am I happy? How can I verify that that's correct? The x coordinate of the vertex is negative 1. Does that make sense when we look at our graph? Yeah, negative 1. Right in between our two x-intercepts. Okay, so let's find the y value of the vertex. Negative of negative 1 squared minus 2 times negative 1, which is negative 1 plus 2, which is positive 1. So the vertex is negative 1, positive 1. Now, why is it that the vertex is above the two x-intercepts? Maybe we should do a parent graph. If the coefficient in front of the x squared is negative, it's a sad U. So it all fits into place. We're done. You guys are amazing. We just came out of Christmas vacation. We reviewed everything we learned in first semester about quadratics and then learned new, but we really need to review. We needed to review all of that from first semester. Okay, we are done. Thank you for coming. I'm going to stop the recording.